Thank you so much for being here with us. We are going to be covering a very exciting topic, data-driven sustainability. So investor pressure has been the main driver behind voluntary sustainability, ESG, performance metrics disclosure so far. But this is shifting right now. It's shifting from voluntary reporting to mandatory reporting. And this is coming from the regulators in the US primarily and the European Union. So this mandatory shift in reporting will put quite a lot of pressure in companies to have to report on their ESG performance. So the pressure is on. I like to call this time equals zero. The time is now. So today we have two fantastic speakers that will share how to successfully operationalize sustainability. In other words, how to achieve both a traditional return on investment and also a return on sustainability. So with us, we have Anissa Thomas, currently leads the Digital Solution Engagements for Sustainability and Energy Transition at Sensia to help clients achieve their ESG outcomes. She also serves as the Chief of Staff of Sensia Sustainability Council. And we have James Hind, who's the CEO of Energy Drive. James is both a leader and an investor in the company. And what attracted him to Energy Drive is the specific focus on energy optimization as a service, utilizing proven BSD technology and deploying this into heavy industry. And with us, Anissa.
Thank you so much, Andrea. Good day, everyone. It's a pleasure to be here to share on data-driven sustainability best practices from our perspective to drive productivity and sustainable outcomes. So these are well-known industry challenges to increase oil and gas production, to reduce time to first production, to reduce operational costs, to mitigate against risk, in addition to decrease our carbon footprint. When you look at those in the context of being able to address the global climate challenges in addition to energy security and the energy trilemma, energy affordability, and the climate crisis, these go hand in hand to be able to drive digital activities. So based on that, the importance of leveraging data to achieve outcomes, and I apologize, this seems to be advancing on its own, to achieve outcomes is critical. So it's well established that if you look at a typical offshore oil rig, there's approximately 2 terabytes of data that's available. Oftentimes, less than 1% is actually useful, and in some cases, up to 50% of producers can't integrate that. So the key factor becomes leveraging the right data to be able to optimize on those potential benefits, potential cost savings, and potential production increases through utilizing data to drive productivity as well as return on sustainable objectives. So with that in mind, the question then becomes not necessarily whether to digitalize, but how to do so. And it's through leveraging different, It's through leveraging the optimal process of connecting, integrating, transforming, and implementing those technologies, we're able to progress that journey. Now, it doesn't start with simply connecting the devices. In our experience, we've seen a critical factor comes from first discovery period, understanding what's available, what are the challenges, and then prioritizing on where to focus. In our engagements with certain clients, uh, principles such as utilizing a digitalization index that would then qualify or identify areas that would produce greatest return in terms of value aligned to the capital spend. Those are critical areas to focus on to initiate this process. So moving forward, what we see in leveraging edge to enterprise type solutions, those solutions need to be scalable, they need to be secure, need to also be able to have that flexibility to be deployed on the cloud, on premise. In addition, having that availability is key. What is also critical is that human factor of having that ease of use, that customization, to be able to have one integrated user interface for multiple users depending on your role in the organization. All of these leading towards those productivity outcomes to drive your sustainable decisions. So based on these specific features, this is a typical hierarchy of what that may look like in the asset. So looking at oil and gas operations, if you look at the lower layers, you would see data driven from your intelligent assets, from your intelligent assets at the field that would then ultimately move towards having that autonomous control, edge analytics control, and intelligent automated control at the edge, in addition to optimization, all linked to a real-time analytics engine, which will then have that real-time optimization to drive productivity gains. And then being led now and interconnected at the enterprise layer to be able to have that integration and collaboration. So this is one example of what that hierarchy looks like. In addition, these are some applications from an oil and gas perspective where I'll touch on a couple of those as we move forward in terms of optimization. In addition to some specific lift applications. A key element as we're looking also at productivity and being able to address specific needs, being able to address the need to report on emissions uh, in addition to optimization required for processing equipment. These are important factors that can be included. So in addition to that, looking at some scenarios we see for lift surveillance, response prioritization for ESPs, or automated gas lift optimization, some results we can see that you can have potential in certain clients for savings of up to 15% of gas optimization, in addition to fewer manual interventions by up to 85%, and also driving response time in terms of minutes rather than days, all ultimately leading to a lower carbon footprint. So it seems as though you're getting a sneak peek of a lot of these slides before we actually get to them, but do bear with me. It's quite interesting juggling act. But nonetheless, the content therefore shows, and this so in transitioning from the wellhead to the pipeline in terms of optimization, I'd like to highlight a couple benefits in this particular use case where through the use of throughput optimization, thermodynamic models, we're able to address savings for our customer in terms of heater optimization, heater usage, reduction in heater usage, reduction in methanol usage to inhibit hydrate formation, and in addition to increasing the pipeline throughput. So these are savings that were realized for a particular operator to the scale of 96% in reduction in duty cycle, 65% in reduction in methanol usage, in addition to 20% increases in throughput. So this particular application can also be utilized in the context of carbon capture, storage, and utilization, where that model is used for the conditioning space in terms of acid gas dehydration prior to injection, where when you look at the different aspects of carbon capture, utilization, and storage, uh, from a measurement perspective, using devices to be able to measure all phases of CO2, the incorporation of that from an automation standpoint as well, leveraging existing tools for storage from a petrotechnical suite of software capabilities, which is one area of focus that was discussed here at the conference this week, using the existing tools to optimize and move and transition those to existing technologies. In addition to the monitoring and control aspect from the real-time digital operations platform, those are areas that can be leveraged to drive digital solutions within these decarbonization efforts. So that said, given the need that right now, going forward to 2050, there's a need to have storage capabilities in a gigaton magnitude, utilizing and leveraging these solutions, utilizing automation, emissions reporting, optimization of your production, are all geared towards addressing, one, the regulatory requirements, in addition to the broader global challenge that we face from a climate perspective, as well as addressing and balancing the energy security and accessibility needs globally. So that said, these are some findings for the deployment of certain solutions with potential savings through throughput optimization from 3 to 7%, potential carbon footprint reduction of 60%, and increasing well-time production. So these results were determined based on specific synergy type joint deployments or direct deployments by our team. So with that, I'd like to highlight that it's very important to make that start, to be able to assess where you're at, and we're here to work together to be able to define that going forward. So I'd now like to transition to James, who would discuss in another industry specific case studies that would focus on commercial engagement models in addition to specific application use cases to optimize and guarantee, to optimize, your return on your investment in addition to your return on your sustainable initiatives. So thank you so much, and this has been quite a juggling act. I appreciate your patience and look forward to any questions at the end. James?